So for this section, we are going to talk about the volume by shell. So volume by the shell method. Let f and g be continuous function with f of x greater than or equal to g of x on the interval AB. If R is the region bounded by the curve y is equal to f of x and y is equal to g of x, between the line x is equal to a and x is equal to b, the volume of the solid generated when R is revolved about the y-axis, that's important, is equal to V. V is equal to the integral a to b 2 pi x times parenthesis f of x minus g of x dx. So again, this is the formula for shells. You need to know the 2 pi x is nothing else but is the shell circumference. Okay, that is the shell. And f of x minus g of x is the height. Is the shell height. Okay, so let's do the first example so you know what we are talking about. Example, let R be the region bounded by the graph of f of x is equal to sine x squared and the x-axis, and the vertical line x is equal to square root of pi over 2. Find the volume of the solid generated when R is revolved about on the y-axis. So again, all the time, try to have a graph if possible. So let me try to make the graph of sine x squared would be something like this. You can don't mind my graph to be like this curve. Okay. All right. So let's say this is square root of pi over 2. This is the region R, right? R is here. And don't forget the shell radius is x in this case. The radius is x and f of x is what? Sine x squared, right? So the height So the height of the shell will be what? Sin x squared. So this is what will be revolved. Let me show you the 3D version of this graph, what you would see. So you can see this is what will happen. You see, this is the height of this sine ball will be sin x squared. The shell radius is x, and of course the circumference is 2 pi. So if I'm solving this one, this is what you need to know. My v will be what? The integral from a to b, 2 pi x times f of x dx, because the height in this case is f of x, right? Which will be the integral from 0 to what? Square root of pi over 2 pi x sine of x squared dx, right? And then now the rest is to solve this integral. So to solve this one, again, 2 pi is a constant. So we can take 2 pi out, and we will get 2 pi, or let's not take 2 pi, because I can say I'm going to integrate using substitution. So I would just said this is sine of x squared. Let me just say let u be equal to x squared, right? So if u is x squared, then du will be what? 2x dx. So you see, I have 2 times x, right? So I can rewrite my following. Before I substitute u, I can take pi out and put sine of x squared, this 2x dx, so times 2x dx, right? Do you see it? This is just to substitute easily from, of course, we have to change the limit of integration as well, because we can see if x is 0, then u will be 0 square, which means u also will be equal to 0. But if x is square root of pi over 2, if you square root of pi over 2, square and square root will cancel out, so u will be what? Pi over 2. So whenever, if I change the variable to u, then the limit of integration also will be changed. So now this was from 0 to square root of pi over 2. But since I'm using a u substitution, I will have we will have pi, the integral from 0 to pi over 2 now, sine of u du. What's the antiderivative of sine of u? That is negative cosine of u, from 0 to pi divided by 2. So we know if you substitute pi divided by 2, cosine of pi divided by 2 is 0. So we will basically have pi will be equal to 0 minus cosine of 0 is 1. So because this negative will make it negative 1. So the answer would be pi. So in this case, the volume will be equal to pi. And that's it. So again, let's move to the next one. On this example, let R be the region in the first quadrant bounded by the graph of y is equal to square root of x minus 2 and the line y is equal to 2. Find the volume of the solid generated when R is revolved about the x-axis again. So again, if we sketch these two equations, you know, the graph of y is equal to square root of x minus 2. If you sketch that graph, let's say 2 is right here. That shape will be like this, right? And the line y is equal to 2. If let's say this is 2 right here. Right? So this is the line y is equal to 2. And this is the graph of y is equal to square root of x minus 2. So about the y-axis, so this region will be my r. And what is the radius? In this case, the radius will be y, right? So you see, this is the interval of integration because it's about the y from 0 to 2. Okay? And if you check to find this point, it's easy. You solve 2 is equal to square root of x minus 2, you square 4. So this point is 6, 2. So now, to solve this one, so you can see the revolution is about the x-axis. So the integration in the shell method is with respect to x. So which means we are going to use the same formula, but in this case, my v would be like from c to d 2 pi y f of y minus g of y dy. And do not forget, this is the circumference and this is the height, right, of the shell. So which means we need to solve my y. The y is equal to square root of x minus 2. We have to find the inverse function. We have to solve for y. Okay? And to do that, that's easy. You square both sides, we will have y squared is equal to x minus 2. We add 2 on both sides. So y squared plus 2 is equal to x. So which will be my f of y. So in this case, it's about the y-axis. So it's about the x-axis. So the height is just y squared plus 2. So the volume in this case will be the integral from 0 to 2 pi y times y squared plus 2 dy. And then we solve. And of course, we can take 2 pi out the integral, so which will be 2 pi. The integral from 0 to 2, we distribute this y, so we'll have y to the power of 3 plus 2y dy. And then you know the rest. You know how to integrate this one. This will be 2 pi 1 over 4 y to the power of 4 plus y squared from 0 to 2. So of course, if I substitute 2, I will have what 2 to the power of 4, which is 16. 16 divided by 4 is 4. 2 squared is 4. 4 plus 4 is 8. 8 times 2 pi is 16 pi. So this answer will be V will be equal to 16 pi. And that's it. So for our next example, let R be the region bounded by the curve of y is equal to square root of x, the line y is equal to 1, and the x-axis. Use the shell method to find the volume of the solid generated when R is revolved about the line x is equal to negative 1/2. So again, let me try to sketch that. So the graph of square root of x again will be something like this. Let me okay, and let's say this is 1. So the line y is equal to 1. You know what? Since this is a, let me move it to the right a little bit because I will need. This is the line y is equal to 1, so this is 1, and this is the graph y is equal to uh, so this is for A. So using the shell method, we must imagine that taking slice are parallel to the y-axis. Parallel to the y-axis, right? So we know a typical slice through R will be So a typical slice through R at a point X where 0 is less than or equal to X, X is less than or equal to 1, has the height. So has the height of 1 minus square root of X, right? So we'll have the height of 1 minus square root of X, which is the height. Okay. And when the slice is revolved about the line X is equal to negative 1/2. So you know this is why I changed this one. Let's say this is negative 1/2. Then the cylindrical shell with the radius inside of X, the radius will be X plus 1/2. That will be the radius and the height of 1 minus X. So a slice modification of the standard shell method gives the volume of the solid, which would be V will be equal to the integral from 0 to 1, 2 pi, because the radius is X plus 1/2. So X plus 1/2 times the height, which is 1 minus square root of X dx. So again, this would be the circumference, and this would be the height of the shell. And this will be the height. So we need to solve this one. So which will give us 2 pi can go out and we distribute. So if I distribute X times 1 is X, right? X times square root of X, you know, square root of X is X to the power of 1/2. So X times that, 1 plus 1/2 will be X to the power of 3 over 2. 1/2 times 1 is 1/2. 1/2 times negative square root of X will be negative 1/2 X to the power of 1/2 dx. And then we have to find the antiderivative of this, which will be 2 pi 1/2 X squared minus this sign should supposed to be minus, right? Minus 5 divided by 2 X to the power of, 2 divided by 5, not 5 divided by 2. 2 minus 2 divided by 5 X to the 5 divided by 2 plus 1/2 X, then minus 1/3 X to the power of 3 over 2 from 0 to 1. So you know, if I substitute 1 and use your calculator, pause the video, use your calculator, then So the volume will be 8 pi divided by 15. So we'll do exactly B the same way, okay? B, use the disk washer method to find the volume of the solid generated when R is revolved about the line Y is equal to 1. Okay, for B, so for B, using the disk washer method, so using the disk washer method, oh no, using the disk washer method, we take this slice. So let me first sketch. So we have to graph square root of x again. And the line y is equal to 1. Okay. Let's say this is R. So of course, this will be 1, right? So the interval of integration will be from 0 to 1. And the disk radius will be 1 minus square root of x. Okay. And then now, the volume will be what? Square root of 0 to 1. Don't forget we are using the disk pi times f of x squared. My f of x in this case is 1 minus square root of x. So f of x is 1 minus square root of x. So 1 minus square root of x squared dx. We expand this integrand. So by doing that, v would be the integral from 0 to 1 pi 1 no, minus 2 square root of x plus x dx. And we have to evaluate this integral now. By doing so, v will be pi x minus 4 divided by 3 x to the power of 3 divided by 2 plus 1 half x squared from 0 to 1. And then if we substitute again, pose, then v will be pi over 6. And that's it. So that's it for this section. Now let's restoring the order. So after working with slices, disk, washer, and shells, you might feel somewhat overwhelmed. How do you choose a method and which method is best? So notice that the disk method method is just a special case of the washer method, if you check. So for solid of revolution, the choice is between the washer method and the shell method. In principle, either method can be used. In practice, one method usually produces an integral that is easier to evaluate than the other method. So you can try both, but you need to know which one is easier for you, right? The following table summarizes method. So we have integration with respect to x. We talk about the disk washer method, about the disk method is just when g of x is 0. That's it. And we still the same thing as the washer method. Okay, so if the disk washer are perpendicular to the x-axis, pi will be equal to, the volume v will be equal to the integral from a to b pi f of x squared minus g of x squared dx. Outer radius, inner radius. But if it's just the disk method, we will just have a function. G of x will be 0. And the shell method, about the y-axis. The shells are parallel to the y-axis. So it will be what? 2 pi x, which is the shell circumference, f of x minus g of x dx. F of x minus g of x is the shell height. And when the integration with respect to y, and then you see the disk washer are perpendicular to the y-axis. So this is the formula you need to know. I will see you in the next section. Practice and you'll be good.